Hello, students. My name is Professor Waugh, and I've been teaching college chemistry for over 31 years. For today's lesson, we're going to learn about addition and subtraction with significant figures. Just like with multiplication and division, performing addition and subtraction operations in chemistry are a bit different than you would do in your math class. All right, let's start class. Quick note before we begin, we have a website. There you can find all the notes we write for our videos. We also have quizzes and assessments, so go check us out. Thanks. Addition and/or subtraction with the sig fig rules. The method is real easy, but you've got to remember, in order to do addition and subtraction, you must make sure that all numbers are in the same power of 10 first. This is all about precision of your numbers, and you cannot analyze your precision unless the numbers are in the same power of 10 when you're adding and subtracting. So you report your answer with the same number of digits after the decimal point. My students came up with DADP as the number in the operation that has the least number of DADP, digits after the decimal point. Now, all of these resulting digits are significant. Let's look at an example. 7.3 plus 8.90 minus 7.620. Sometimes, again, I think that lining up the decimal points makes it so easy for you to analyze your problem. So remember, rule number one was to put all numbers in the same power of 10. All of these digits are 10 to the 0, right? Because I know you know 10 to the 0 is the same thing as 1. So when we look at the first number, 7.3, we only have one digit after the decimal point. Plus 8.90, that's two digits after the decimal point. Minus 7.620, three digits after the decimal point. So our resulting answer must have what? One digit after the decimal point. So we box it in, 23.8. Outside the box is a 2 and a 0. So that means that 2 says I don't have to mess with that 8. Leave it alone. So the final answer is 23.8. Remember, everything in front of the decimal point is significant. So it's 23.8 in decimal form or 2.38 times 10 to the 1 in scientific notation. Now let's look at an example with numbers with different powers of 10. Remember, in order to keep the precision, all numbers have to have the same power of 10. So let's take the second number, which is 6.990 times 10 to the minus 5, and change that to 10 to the minus 4. As one goes up, the other goes down. As one goes down, the other goes up. 10 to the minus 4 is larger than 10 to the minus 5. So the decimal portion has to go down as the power of 10 goes up. So the number that we will add will be 0.6990 times 10 to the minus 4. Once we do this, with everything being in 10 to the minus 4, we can see 8.235 times 10 to the minus 4 has three digits after the decimal point. 0.6990 times 10 to the minus 4 has four digits after the decimal point. So our answer can only have three digits after the decimal point. So the resulting number is 8.904 times 10 to the minus 4. That's in scientific notation, and that's wonderful. Thank you for attending class. To recap, before doing any addition or subtraction operations, make sure all of the numbers have the same power of 10. After you do that, it becomes a simple matter of completing the operation. However, you have to pay attention to how many digits after the decimal point are in the result. You've got to have the least number of digits after the decimal point in your final answer. All of those resulting digits will then be significant. So this becomes important when we look at the next video, and that's all about the PEMDAS rules. Once again, thanks for watching. We are A Friend in Chem, and our mission is to help students learn introductory chemistry. Our email and website is in the description. So if there's any way we can help you, please contact us. We want you to be successful in chemistry, enjoy chemistry, and have fun with chemistry. Until next time, take care.